Check 1, 2. All right. We'll go ahead and get started. Some folks are trickling in. My name is Wynn. I work at GitHub on the API team. I think there's 3 of us here this year, so we've kind of descended upon Grapevine. Online, I answer to Penguin, Twitter, GitHub, the usual places. Splash page is up at wynn.fm, which is also a gospel R&B station, I think in North Carolina, somewhere around there. But you can find me, wynn.fm. Today I want to talk to you about changing code, and this is somewhat of a technical talk, but for the most part it's about the philosophy of how we work at GitHub and how we change code. So I don't know what you've been told, but changing code is pretty easy, right? You just change it. It's changing code with confidence that can be the kicker. And I think we all know how this scene ends, right? With production rolling down behind you. So how do we get confidence about changing code? I think tests are probably the first thing that we do. We write lots of tests. As we develop features, we write tests, we find bugs, we write more tests, and over time we have a test suite that grows with us. Anybody less than comfortable with their test suite for their production apps? It's okay. You know, there's certain things that you test down closer to the metal that you're just less than confident when you make those changes in production. At GitHub, we use data to inform decisions. And this is one of the things that kind of transformed the way that I worked. I've always used tools to gather metrics, especially around usage of physical utilization of boxes and things of that sort. But at GitHub, it kind of blew my mind of just what's possible when you track everything and use that data to inform decisions. So we use Hubot for chat ops, for everything. It's kind of like the center of the world at GitHub. And in that is a GraphMe command where I can pull up a graph, a visualization of just about every metric that we've got that we track in the application. In this case, we're tracking API status codes. It's just an example. Work on the APIs, it's usually mine are API related. Just API status codes over time and see if it meets expectations around certain changes that we're making. Here's another one for serialization queries when we're taking active record objects and serializing those to send over the wire in API responses. So having rich data like this can inform decisions and help you move with a little bit more confidence. We don't like to break the API at GitHub. Nobody does. But there's been times where we went from a really dogmatic, we can't break the API approach to actually seeing who's using particular methods and reaching out to those folks and then making a more pragmatic choice. This is powered by what we call the Graph Store. It's powered by Graphite. There's tons and tons of graphs in this thing. And if it doesn't have the graph that you want, you can just go and save the visualization and build that and save yourself some work the next time. So it's built on Graphite, as I mentioned. We have everything from broad visualizations and dashboards like this. This is what pops up when you do a deploy in Campfire. Hubot will tell you, check the Graph Store, GraphMe, for the browser response times to see if the change that you introduced is making the site run slower or faster for the segment that you care about. I did a little DOM work in Chrome just to hide all the scrolling and just to get a screenshot of all of the charts. This is probably 10% of what was available on the first page. It's just tons and tons of these charts that you can pull up and gauge metrics as you're building out things. And we track these. There's 3 basic things that we track in the application. There's counters, gauges, and timings. So a counter is usually the most common. Anytime something that we care about happens in the code, we will just increment it, give it a name in its namespace and some sort of action, and that will increment a counter so that we can then take that and go graph that in the Graph Store. There's a gauge if you want to track a reading of something over time, like CPU utilization or Holman's Twitter followers or something like that, right? You can measure that over time and see how that grows or shrinks. And then a timing gauge is where we wrap a particular method in one of these Graphite calls, and whatever's inside the block is we're going to measure the duration of that and store that in Graphite. So armed with that data, we now can deploy with a little bit more confidence. And so I have to temper the talk. The frosted side of me likes to kind of talk about all the cool things that I've learned at GitHub and how we work at GitHub. And I forget that not everybody has got the same context that I do. Who here was not telling a computer what to do all day before Y2K was a thing? Yeah, it was not. Anybody not coding before the year 2000? Fair number of hands. So sometimes I feel like I've got to go back and give a backstory just to kind of appreciate how good we have it on certain technologies that we have today. So I started programming the late 80s. This is effectively what we call the Trash 80, TRS 80, writing BASIC. And so deploying back in this time was usually just writing it down and turning your homework in. I don't even know that we had floppy drives on those. We had tape drives, but didn't have a tape drive at home. So usually homework was in written form. So that was shipping in 1989. 94 in high school, it was floppy disk. I had a computer literacy teacher that effectively called these hard drives because they were harder than the 5 1/4 disks. And then moved into college and we leveled up to zip disks. Those held 100 megs. They seemed huge, or 120 maybe. My first real job was in 98, 99, working at a paper as a webmaster. Back in college, assistant webmaster. Actually, the webmaster was the one that did all the IA and the site design and all of that. The assistant webmaster had the privilege of copy and pasting out of Quark and into the Adobe Go Live or whatever company it was before Adobe at the time. And that was deploying back then, was copying and pasting and FTPing. Moved into .NET development, where deployment then had massive build documents and Word documents, and usually involved going with manual instructions going into the Microsoft console and registering COM components and things of that sort. So big, nasty deployment scripts that we had back then. I drank the Kool-Aid and came over to Ruby and Rails 2006, 2007. And by 2009, I felt like I was living in the future with Capistrano to be able to deploy over SSH and script your deploys. And that seemed great, and did that for a number of years until moved over to GitHub, and it just blew my mind the way that we deploy and how often we deploy at GitHub. So deploying today is mostly the GitHub Flow with some Hubot and pixie dust sprinkled on top of that. It starts with a pull request. Anybody not using pull requests for the bulk of their the majority of their development? Cool. So you'd be surprised when I give this talk, and it's just a lot of folks are using Git and just haven't embraced the collaborative side of Git. So it starts with a pull request. This is an actual bug that I shipped a couple of weeks ago. So to create a pull request, create a branch, add some commits, push that up to GitHub, open the pull request up there, discuss and review, and usually that's an iterative process. I've got an open pull request right now that about 5 or 6 of us are working on, and I think we're stress testing the pull request page if it can show the diff stat for that thing. So this is an iterative process, and then based on the GitHub guide graphic that I stole, you merge and deploy. But in the case of GitHub, we usually deploy and then merge. And it seems kind of strange the first time that I saw it, but this is usually how it starts. Once you get a thumbs up or a ship it squirrel that your code looks good, right, then you deploy that to production. So the workflow that I'm about to walk through is based on actual events. Change the SHAs to protect the innocent. So it starts asking Hubot, where can I deploy? And Hubot will come back and tell you the state of all of the environments. We have a production environment. We've got lab environments of varying degrees. We've got something new that I'm really excited about. A couple of weeks ago, Aman Gupta cobbled together a branch to VM deployment process that is essentially a branch lab. So you can deploy your branch, and it is live on your branch name, whatever our test environment is, .com. So you don't have to wait on the tarmac to taxi to deploy anymore, which is really cool because when several of us are in there working on the website, you spend as much time waiting in line as you do deploying. So we ask Qbot, where can I deploy? And then you tell it to deploy which project, in this case, GitHub, the website, which branch that you want to deploy, to which environment. The default is production, so if I omit production here, he assumes that I mean production, but I could deploy to any one of those labs that I mentioned. I could also deploy to just the front-end servers. If I'm doing a front-end change, I could deploy to auxiliary back-end servers if I'm just doing a migration or something like that. So environment's not strictly what we think of as a Rails environment or a machine environment. Once I do that, usually this is the first notification that comes back. Qbot will check to see if master has been merged into my branch. And if not, he'll do that for me. If master has been, he'll just go ahead and start the deploy. But the first thing that he does is check that master, the tip of master, has made it into my branch, because we always want to deploy green code to production, and master should always be green. So once we get up to date with master, then we wait on CI. And again, we use Janky, which is Qbot on top of Jenkins. Anybody using Jenkins? Cool. It's one of the better ones out there. The UI is horrible, but if you're using Jenkins and you haven't tried Janky, you might want to do it just to save your eyes. I really dig the interface for Janky. While we wait on CI, I can go check email or be productive, or let Qbot entertain me in other ways. Go check out the water cooler room, hang out with some other folks. Go back and check on CI, and eventually he'll come back and tell me that everything's either red, which I start the deploy process over, go fix the test, figure out what's janky with Janky. Or in this case, I have a green build, so it's going to deploy that directly to the environment that I selected. In this case, production. So he's going to lock production. Nobody else can build to production. And off we go to deploy our codes. We'll get a call back that the deployment has started. That still takes multiple minutes to deploy all that code up to production. And I get a notification when that is done, and then I can go bang on it. That's how it always plays out in my head anyway. So we've deployed our code to production. And now we observe. We've got several tools that allow us to observe code that we've deployed to production before we merge it into master. One of these is the staff bar that shows metrics up at the top, not only site-wide response times look like, but for that particular controller action to let me know if I've slowed down or sped up a particular view, or if we have problems in the rendering in some way. This is really cool. Most of my work's on the API, so I'm in curl and shell poking on production for the most part, but this is available if you're doing something UI-related. Another thing that we've got, in this tool, this previous tool is very similar to, anybody using New Relic for this? I like New Relic, it's pretty cool. Haystack is an internal tool that you could think of it as a hop toad or an air brake exception notifier that we catch all the unhandled exceptions. They land here. We call all of them needles. Go find a needle in the haystack. Up top, we have browser response time period over period to see if we've slowed down the site, and then exceptions period over period to see if we're introducing new exceptions, unhandled exceptions on the deploy. And then you see those listed down below. We have avatars that are on a timeline, so you can see who's doing deploys when, and you can see the exception started right after my deploy. I bet you something's wrong with my code, right? I can click on an exception and dive into it. We have the stack trace linked up. The orange lines that I've blurred out are proprietary code inside of the GitHub code base. The white ones are open source vendor gems that we use. And if we have the source available, in the case of the orange or the white here, I can click on that, and it takes me out to that line of code on GitHub directly, so I can see exactly what's going on. So it's handy to have that stack trace. And they're even over in the gutter color-coded, so there's a little octocat if it's GitHub code, and it's a gem icon if it's just a vendor gem. So what do you do if there's a problem? Well, we want to be able to roll back quickly to a good state. So if we see that exceptions are coming in, And there's been times where the test suite was green, I felt really confident about a very small change and deployed that to production and watch Haystack light up. Need to roll that back quickly. Just Hubot deploy GitHub without a branch, without an environment. He'll throw master directly into production. And so you're only waiting as long as it takes to get a deploy to get back to a good state. And then you go off and fix your test or figure out what's wrong and investigate. If everything looks cool, we can merge that down. And I could do that from the command line, but mostly I go out to the pull request that was open and just hit the merge button. And as soon as I do that, Hubot will notice it. There's an event callback. He'll say, it looks like you merged your branch into master. I'm going to unlock production for someone else now. And then he'll kick off builds if need be to throw that back into production. Master can move while my code was up in production. Although we've locked the environment, master, there's other people pushing changes. We can push copy changes and other things that don't require CI build directly to master without even going through CI. So if that's the case, and master did move, it'll do one more round of tests and then deploy the latest code to production. So that's how we deploy with confidence. Being able to gather data, be informed about the state of a deploy helps us move quickly. But there's times when we need to know if we can remove code and act with some sort of confidence to be able to remove code with a high degree of certainty. Have you ever asked this question when you opened up a class and you're exploring, you're trying to understand something, and it may be a class that you camp out in regularly, and then it finally dawns on you that this method that I've been dancing around, I'm not even sure if it's still legit, right? So how do we find the cruft from previous refactorings or feature removals and get rid of that with a high degree of confidence? At GitHub, we use something called Backscatter. This is not open source, but you can roll your own. It's a fairly simple pattern. Rick Bradley created this, and it lives within the GitHub code base. Think of it as star 69 for Ruby methods. So in a dynamic language like Ruby, it's often hard to know where things are called from, especially with all the metaprogramming going on. A simple grep won't always show you the caller of a particular method. So here's a very simple case. We can include GitHub Backscatter in our class and instrument a method accordingly. And what this will do is trace every time that method's called and put it in our staff tools, the same visualizations we showed earlier, and show you where and when and the duration of these. And these links to the methods are linked to the source code, just like Haystack was, so I can click through those and see exactly what line of code is calling the method. A lot of methods might be too heavy to trace every time through. So in this case, we can add 1,000 here, and we're only going to trace one out of every 1,000 calls through that method just to get a sampling of the throughput of that particular method. So deploying with confidence and removing code with confidence, science, as I framed the talk, is about experimenting with confidence. We refactor a lot of things at the very core of the business, especially around security relationships and things like that, that what worked for 20,000 users doesn't work for 7 million users, right? So as you see growth in the product, you have to refactor the code base to keep up with that growth. And there's certain times where you've been so dependent upon framework magic under the hood that you might not have a high degree of certainty when you go to move things around that you haven't changed behavior. So even though we have substantial tests around those things, you would like a little bit more confidence to know that you're not going to be impacting production as you move and refactor. So we use a project called Science. It lives at GitHub/dat-science. That's kind of a meme at GitHub we use for everything. In our console helper, our console, Rails console, there's a dat helper. So you can just say dat mojumbo or dat defunct as a string or a symbol, and it pulls back their user record, or dat and a owner/repo slug, and it will pull back that repository record. Just saves you from having to use the finder methods. So dat's baked into a lot of things we use. It's brought to you by John Barnett, who lives in New Orleans, and Rick Bradley, I think's in Nashville. I'm not sure. So they created this science project and have extracted it out of the GitHub code base, but it's what we use internally to experiment. And I was excited when I found it. I saw this in the Fail blog a couple of weeks ago, and I thought, that is just perfect for my talk. So it allows us to safely observe alternate code paths. So given a class that looks like this, we can create a new experiment, give it a name, and then we introduce two code paths. The control group is the old way, the current way, the production way, which should be the correct way, and then a candidate method. And both of these are just blocks, right? So control is just a block. Usually this will probably be a do end unless you've got that down to a single method that can fit on one line. But this is to simplify it a bit. And then a candidate method, and then we just run the experiment. There's even a DSL for it, if that's too much typing for you. Science, and the name of the experiment do, and pass it the control and the candidate, and it will create the experiment and run it in a single step. Some other options that you can pass to this. So what's going to happen is it's going to run the control and the candidate group every time through. It's always going to return control, but it's going to publish the results based on how you configure it. Publish the results when control doesn't match candidate. So it lets you know when your two code paths aren't in sync as you expected. If you have each control and candidate group, if you need some hints for how it should compare the results of those, you can pass it a comparator, as we do on this last line, and tell it how to compare the control group to the candidate group. So ramping up experiments, just as we did earlier with the trace call with Backscatter, we probably don't want to trace every time through some of these, especially if they're in methods that get called on every page script. We can ramp those up just by, in our experiment class, overriding enabled. The default is true, which is every time. Here we can give it a 10% throughput, so every 1 out of 10 times it's going to be enabled, and that way we get a sampling of data. And we've set it up in GitHub that there's a model around this, and in staff tools we even have a nice UI that we can go in and ramp up these experiments over time. Another option is use something like jnunemaker's Flipper project or the rollout project, I think uses Redis, to ramp this up over time as you go without having to hard code this and do a build to be able to enable an experiment. By default, science doesn't do anything with your results. You have to publish them. So override the publish method. In this case, we're going to use similar instrumentation that we used previous in the talk to throw those metrics up somewhere. In the case of GitHub, we have a staff tools page that logs these. And so these are some of the experiments that we're currently running. The green, everything is matching up. If you see a lot of red, it's where the candidate group is out of sync with the control group. So we have some metrics over here, how many times it was run, what the current throttle rate is, and then the percentage that it was right or wrong. Helps us know as we're moving through the code base and changing things, how we can bring the candidate group into sync with the right results with the control group. I can drill down into those experiments and see accuracy over time. So was it accuracy, the accuracy less or greater over a time x-axis there? And then performance. We also track the duration of the control group and the candidate group. So for the candidate group especially, to compare those, even though we're returning the right results, what's performance look like based on the current behavior that's in production? And I mentioned the UI. This is, found out the hard way. These looks surprisingly like pagination links. The first time I clicked that, I was thinking I was going to page 2 of results, and I was playing with somebody's experiment. So Adding custom context to an experiment. So there might be cases where we want to log not only the duration and whether, how correct the candidate group was for the experiment. We might want to throw some extra context, the actual user or post or something else like that. Custom payload into the experiment and log that, so when we analyze it, we can figure out, was it a post, was it a data issue or something like that. In the GitHub code base, I discovered when I was looking through the code to prepare for this talk, didn't even realize this was there. There's an override called dat-science. That was pretty cool. So this is in the GitHub namespace, and all it is a dat-science accessor method here, and it flips, returning candidate instead of control. So if you're really feeling lucky, you can return the candidate results instead of the control results from your science experiments. This is kind of just a taste of what analysis that you can do based on the science experiments. But if you really want to dig in and analyze the results, not only visualize the results as I've shown here, but maybe poking them from the console. There's another project called dat-analysis. It's also up on GitHub that will allow you to compare the results and fetch the next result off the queue and bang on those in a console setting. So if you prefer text mode, you might want to check that out. I just wanted to end real quick with one last thanks for the impact that Jim Wyrick had on the community. At breakfast yesterday when I got the news, I was listening around to just some of the ambient conversations. I didn't know Jim that well. I met him 2 or 3 times at conferences that I was fortunate enough to share a stage with him. And, I always thought of him as the guy who wrote Rake, as just one of those guys that was up the road and who I looked up to tremendously. But listening to the conversations yesterday, one thing that struck me was very few of them were about what he created, the tools that he created, any of the projects that he created. They were more of the personal impact that he had on people's lives. And the thing that seemed to strike me was the humility that he had, just the zeal for life that he had, and this notion of making the community a better place. And if you just see the impact that just one humble programmer can have, it just kind of makes me think I want to focus less on identifying with the code that I write. Doesn't mean I want to write worse code, but I want to identify less and separate myself from what it is that I'm creating and really focus on the relationships in this business, the relationships in this community, because I think that's what's most important. I thank you for your time.